In this video, I'll do an overview of Hyper-V. The Hyper-V product comes in a number of different flavors, one of which is Client Hyper-V. This one is designed to run on Windows client operating systems such as Windows 10. However, your Windows 10 station would still have to have the proper hardware support. Now for Client Hyper-V, what that means is it would have to support second level address translation, or SLAT. Client Hyper-V does not support failover clustering. And what this means is that it's useful in a testing environment, but you wouldn't use Client Hyper-V to run production virtual machines. The standalone Hyper-V server product is a separate installation and configuration. It's similar to Server Core in that once it's installed, there is no local graphical interface, but there is local command line access. We could use remote graphical tools, however, to manage our standalone Hyper-V server. We could even join it to an Active Directory domain or join it to a failover cluster. So the standalone Hyper-V server product then is free, but the guest operating systems you run on it will have to be licensed properly. We could also install the Windows Server role for Hyper-V on a server that already exists. This is installable in the Windows Server Technical Preview code. We could also install Nano Server, which is designed as a very small, lightweight server operating system that's optimized for cloud use for applications as well as running virtual machines. We can manage our Hyper-V hosts locally or remotely. We could use the Graphical Virtual Machine Manager tool. This is part of Microsoft System Center, so it's not included automatically. You have to download, install, and license it properly. VMM, the Virtual Machine Manager, has the ability to manage multiple Hyper-V hosts in a single interface. We also have the option of creating storage quality of service policies in the VMM GUI. Storage quality of service policies allow us to control the disk usage in terms of minimum and maximum disk IOPS against a group of virtual hard disks instead of doing it per single virtual hard disk. Here in the Virtual Machine Manager, in the left-hand navigator at the bottom, I've selected VMs and services. And on the left, I've expanded a cluster I've added called Cluster 1. And here we can see a number of virtual machines. So we can right-click on the virtual machine to manage it, such as powering it off, pausing it, shutting it down, migrating its storage, and so on. We can also use other tools, such as the Hyper-V Manager. If I were to start the Hyper-V GUI Manager tool, we can see on the left that we've got one connected Hyper-V host. And on the right, we can see the virtual machines available on that host. And from here, we can also manage the virtual machines. One of the new changes with the Hyper-V graphical management tool is that it uses WinRM to make its connection over the network. We can also use PowerShell to manage the virtual machines running on Hyper-V hosts, as well as managing the Hyper-V host itself. Virtual machines that are created with older Hyper-V versions are not updated automatically when you run them on Hyper-V Technical Preview 2. But there is a new configuration version for the virtual machines. In Technical Preview 2, it's version 6.2. Once you update the version of a virtual machine so that you can use new features like production checkpoints, it's not reversible. You can view the virtual machines running on a host along with their version numbers using the get-vm PowerShell commandlet. Here we can see the result of the get-vm PowerShell commandlet, where we can see the virtual machines that are available on this Hyper-V host, and in the rightmost column, we can see the version, which is listed here at 6.2. We use the update-vm version PowerShell commandlet to update the version of a virtual machine to the newest version, which is 6.2. However, that will be blocked if you're in a clustered environment and the cluster functional level is Windows Server 2012 R2. So once all of the cluster nodes have Server 2016 Technical Preview 2 or Hyper-V Technical Preview 2, we can then update the cluster functional level using the appropriate PowerShell commandlet. New features such as production checkpoints aren't enabled until you update the virtual machine version. When you run the update-vm version commandlet, the virtual machine must be shut down. We can verify the version, as we know, using the get-vm commandlet. When you update the version of a virtual machine, after that's been done, it's not reversible, and the virtual machine cannot run on Windows Server 2012 R2 hypervisors. The new version of a virtual machine also uses an efficient binary file format for the virtual machine configuration file. Hyper-V has system requirements as per Windows Server Technical Preview. That would be a CPU that's at least 1.4 GHz, 64-bit, at least 512 megabytes of RAM, and at least 32 gigabytes of disk space. Now, naturally, all of these hardware requirements will go up depending on your virtual machine density and the IT workloads working within those virtual machines. We also have to consider the fact that we may take checkpoints or snapshots of virtual machines, which consumes more storage space. Also, if we're using direct attached storage or a storage area network, we have to account for the number of virtual hard disks that will be used for each VM in addition to their checkpoints. In this video, we did an overview of Hyper-V.